Hello, Reed Samori, and this is my reply to Carson's presentation. I just want to say great job to everybody. I think we all did a great job in our own way, and we're all hemoglobin experts now. So I think we all pretty much got it right, associating lower pH with less oxygen binding affinity and the presence of carbon dioxide with lower oxygen binding affinity of hemoglobin, which I think ultimately you got to that point, Carson. I do think you glossed over some parts of it, but I think I agree with what you said, associating CO2 production with an increase of proton concentration and ultimately lowering the pH, and that lowering the oxygen binding affinity of hemoglobin and releasing the oxygen. So in that case, I think if the pH were the same in the tissues as it were in the lungs, you would say that there would be no change if that was the only difference. But you did mention the partial pressure too. So because of the partial pressure changes, I think based on your logic, there would still be a decreased oxygen binding affinity, but maybe not as much with just a pH decrease alone. Now, the other component, which I think is where I'm not sure I followed you, or I think I might disagree on, is that when we looked at those oxygen dissociation curves, pH had an effect, partial pressure had an effect, but pH and CO2 had a greater effect. So I think that it's not just pH, it's pH and CO2. So I don't know if you made that distinction or even if it's an important one to make. And then finally, I don't know what you meant when you said that oxygen would release counteracting the pH and bringing it up to that midline. It's not really my understanding that the oxygen release has anything to do with counteracting the pH. I think that's, I think if we're talking about balancing pH in the body, ultimately the weak acid, I think, carbonic acid's gonna help be that buffer. I don't know if oxygen itself acts as a buffer. It's a great question, but when I was learning about this stuff, that's not a point I came across. So unless we have information to the contrary, I don't know that I agree with that at the moment, that oxygen release has anything to do with pH counteraction. It's more that the presence of hydrogen ions and their binding to the polypeptide chains of hemoglobin is what stabilizes the T state from conformational changes. And so does carbon dioxide to some degree. So I think that's why there's a difference between the two, and why having both of them, both the pH decrease and the presence of carbon dioxide, has a greater impact on decreasing oxygen binding affinity for hemoglobin.